everyone. Welcome back to the lectures in the Introduction to Multi-Agent Systems. In today's lecture, we'll discuss one of the most popular centrality measures which is the PageRank centrality. To be a bit more specific, in today's lecture, we'll discuss the underlying logic behind the PageRank centrality and we'll see how exactly it works. Interestingly, it is also a feedback-based centrality measure like the eigenvector centrality. Something that's even more interesting is that the Google search engine that we use today was actually found out of this centrality measure. So now let's get started.
In 1996, Larry Page, along with some of his co-authors, proposed PageRank centrality. Their objective was simply to arrive at a mechanism for ranking the web pages. Let's write it. For ranking the web pages. Now, before we understand how this ranking works, why is it important, we'll also try to understand a few properties that web pages have which distinguish them from other things like academic publications, for example. So before we get to it, now, ranking of web pages is very important. Why? Because most of the search engines that we use, whenever we enter something, whenever we try to search for something, they list out all of the web pages, or at least some of the web pages, which give us information about that particular topic. Now, in the process of listing it, they actually assign a certain rank to each of the web pages and then load them or make them appear in that order. So, and then the thing that we see first, the web page that we see first, is actually the top ranked web page. So that's how these search engines work. And that is why it is also important to be able to arrive at an effective ranking mechanism for the web pages. Okay, so now let's learn a little bit more about the web pages. There are several differences between web pages and academic publications, as I said before. What are those differences? Unlike academic publications, web pages are not peer-reviewed. Which would imply that web pages can actually proliferate despite their quality. Moreover, so this is one of the points, that owing to this very point, what happens is let's say research articles discussing perhaps the same topic as a web page as a web page is often considered to be more credible. Meaning, now we know that the way that we can rank the web pages and the way we should rank the academic citations have to be slightly different from each other, given that they are both fundamentally slightly different from each other. Perhaps not so slightly, they're quite different from each other. So by now we have studied several centrality measures. We have the degree centrality, we have eigenvector centrality, we have cat centrality. So you know that in academic publications, the degree centrality is often used, meaning the more number of times a paper gets cited, then more often than not, people consider it to be a very good paper. So let us ask ourselves this question. Can we in fact use degree centrality measure to rank the web pages? Something which is meaningful for the academic publications. But since academic publications and web pages have very different features, the answer to this question is naturally no. Let's try to understand this a bit more. Why would degree centrality, in fact, not work in this case? Let's try to understand this with an example. Let us look at the set of web pages that are shown here. That the first web page gives us a link to the second web page. When we go to the second web page, it directs us to the first web page. Similarly, each of the web pages has certain forward links from that web pages. Okay. If you look at it more carefully, we see that the second web page, now it has many in links or incoming edges. From which web pages? From in fact, all the other three. Web page 1 directs us to web page 2. Similarly, 3 directs us to 2. 4 also directs us to 2. So we can very easily see that web page 2 is somehow an important web page. Every other web page is directing to it. We can encode the same information in the form of a graph as shown here. So it's exactly the same representation of what is shown here. In that case, what is the challenge when we use degree centrality? Let's write it. Please remember that up to, until we had the page rank centrality, most of the web pages did in fact use degree centrality. Let's write it as the challenge. Challenges people faced while using degree centrality. If search engines use degree centrality, as a ranking mechanism, then as a web page designer or as somebody promoting a certain web page, what should I do? Let's go back to this image a little bit. What I can do is I can create now more such web pages. Suppose I'm somebody who's trying to promote perhaps the first web page. This is just a dummy web page that I created, and inside this web page would be another. So let's say this is web page 5. And web page 5 has a link to web page 1. Similarly, I can create one more dummy web page like this. Let's call it web page number 6. Again, this I can create a forward link from web page 6 to web page 1. I can create many more such web pages, which could now make the first web page more influential than the second one. Meaning, let us say if I'm the one doing the ranking, so then I can falsely create many backlinks for a given web page. What are backlinks? So if we see here, we have added 2 more nodes now. Node number 5 and node number 6. And both of them point to node number 1. So if we see here, if we look at it, web page 1 has many backlinks. Backlinks are simply the incoming edges to a certain node. We see there are actually 4 backlinks now to web page number 1. So let's write it. If search engines now use degree centrality as a ranking mechanism, one can simply create backlinks as a way to favor a certain web page or favor some web pages over others. Effectively, this can be a very easy way to make one web page more influential than the other, which means that, let's summarize it. We can write it conclusively this way. The World Wide Web consists of competing entities, meaning perhaps these are larger firms that are competing to gain market share over a certain product, or it could be for any other thing. However, the World Wide Web does in general consist of competing entities, which can now create links to make a certain web page falsely influential. This is why degree centrality will not be a good way to rank the web pages. So what can we do? What would be a good way to rank them? So that is, before we answer that, let's continue our discussion on the web pages. The next thing that we'll talk about are, in fact, the structure of web pages. In general, every web page in a graph, every web page is denoted as a node. So let me within brackets write node. Has some forward links. What would be the forward links in the case of graphs? The outgoing edges. Every web page has some forward links, and some backlinks. Backlinks are the incoming edges to the node. Okay. Now, given a web page, if we open up a web page, what can we easily do? We can easily figure out all of the forward links from the web page, but it's a much harder problem to actually try to calculate all of the backlinks to that particular web page. That is, we may never in fact find all of the backlinks. Let's state this formally. Given a web page, we can easily find all the forward links. But may never find all the backlinks. However, backlinks can actually give us a lot of crucial information about a certain web page. Let us go back to the same example that we had before. Again, we have 4 different web pages here. Suppose we are trying to search for a certain research topic. Let's look at the web pages again. I've replaced the first web page with that of the web page of some academic institute. Let's say any academic institute which is considered to be very good, okay. Then let us assume that this academic institute has a link to the second web page. Now, web pages 3 and 4, just in our case, let's just assume that they are not web pages which are related to any academic institution. In that case, we are trying to, or we are going to perceive web page 1 as being a very important neighbor. Why? Because people generally tend to believe if we are discussing some academic topic, then obviously the academic institute would be a more credible source for it. And if that academic institute now directs us to the second web page, it adds more value to the second web page. Hence, let us now say this is a very credible source. In that case, 1 is going to add a lot of value to node number 2. So how can we summarize it? We simply say if a web page has a backlink from an important web page, then its credibility is high or higher than another web page which does not have the backing from the important web page, which should naturally imply that this information of whether a web page has an important backlink or not must factor into its page rank. we can simply say page has a high rank if the sum of ranks of all of its backlinks are also high. In other words, if it has very important neighbors. With this, what we'll try to now do is figure out ways of actually coding this information in the form of a formula. So we'll do that in the next lecture. How can we encode all of these things mathematically? Thank you.